Today I am going to discuss the code forces round 891 div 3. Okay. Problem number D, counting graphs. Now we have been given a tree consisting of n vertices here, and we know the definition of tree is a connected undirected graph without cycles, and each edge of the tree has its weight wi. Now we have to count. What our task is to is that count the number of different graphs that satisfy all four conditions. Okay, and what are these four conditions? That the graph cannot have the self loop and multiple edges. The weights on the edges of the graph are integers and does not exceed s. So we have been given an upper bound over the weight we can assign to any edge in the graph we are forming. Okay, the graph has exactly one minimum spanning tree. The graph should have exactly one minimum spanning tree, and the minimum spanning tree of the graph we are forming should be the given tree. Means the tree we have been given should be the MST of the graph we are forming. Now, since the answer can be very large, we have to take modulo with this. Now, uh, talking about the input pattern, we have been given t test cases. Then n is the number of nodes in the tree. We have been given s is the upper bound of the weight we can assign to any edge in the graph we are forming. Okay, then follows the n minus one lines describing the edge. In what manner? Ui vi is the nodes between which the edge is, and w is the weight of the edge. Now let's let's discuss the test cases, then you will be more clear. uh, let's discuss this test case, second test case, 1 comma 2. So this is the given tree. Now one thing you should observe that the the number of nodes is going to remain the same, either we form the graph or the tree. Okay, so it is going to be remain the same. And also this tree means the edges which are part of this MST we have been given would remain intact. Means it is not going to change, because if we are going to just change the values, even if we are going to just change the values between the edges, then our MST will not remain the same as before. Okay, so uh, in this test case there can be eight possible graphs we can form, and let's see how. But before this, let's discuss that Kruskal's algorithm. In this, what we do in Kruskal algorithm is that we just first of all sort the edges in terms of their weight. Okay, so the first edge would be this. Okay, second edge would be this, and fourth edge would be having weight 4. So now in what we do in Kruskal's algorithm, but we would just first of all take the age which is having the minimum weight, and we'll try to add a age between the nodes. Okay, suppose we are going to create the MST for this graph. So first of all, I would try to add a age between 2 and 1. Why 2 and 1 first? Because this is having the least weight. Okay, so yeah, we can add an edge because this is not going to form the loop. Now second, we can add an edge between 3 comma 4. Why? Because then next after 2 it is 3, having weight 3. Okay, so we can add, and it is also not going to form a loop. Now next we can add an edge between 2 and 3. It is having weight 4. So one thing you should observe, now after this, even if I add this or this, then it is going to form a loop. So one thing you should be clear that this tree I have already told that this is the same as this one, and you can see that this tree will remain intact. So how we are going to get different graphs? Obviously after adding this this or this edge. So basically, there can be n into n minus 1 edges if we are having n nodes. Okay. So in case of 4 nodes, the number of nodes can be 6. The maximum number of edges can be 6. And in the MST, obviously it would be n minus 1. So that is we are given only three edges. So that's why we can add at max three other edges, extra edges in this tree. And that's no here also the weight can vary. Weight can vary from the weight we can assign can be between 1 to 5. Okay, 1 to 5. Here it is 5. S is given 5. So you should also observe that why we are only assigning 5, even when we can assign have it any age extra age, means these black edges are the extra edges we are adding. Then why we are assigning only 5 value 5 to these edges? There is a reason behind this. So suppose if I assign it value 1, assign it value 1. So let's suppose this graph itself. Okay, this graph itself, if I suppose assign this as value 1, then what would happen? While forming the MST, this age would be added first. This age would be added first, because this is the rule of the Kruskal algorithm, that we add the ages between the two nodes having the minimum weight. Okay, so now if I add the age between 1 and 3, so obviously the MST you would get for this graph will not be the same as the previous initial MST we have been given, the given MS tree we have been given. Okay, that's why we can't add even 2. Why? Because it is having 2. We can't even add 3 because there exists a age which is having value 3, and we can't also add 4. Okay, so it should be having greater than 4. The value should be greater than 4, and it should be less than equals to 5, according to the constraint that the weight is between 1 to s. So the only value we can assign here is 5. That's why we are assigning only 5. Now the number of graphs we can form is that, see, we can add at max 3 edges. Just listen me properly, this is very important. This that we can at max 3 edges, we can add at max 3 edges, and for all the edges we are having only one value possible. Okay, and also when we are at edge, suppose these are the edges, so there exists two options: either to take this or either not to take this. So obviously there would be 2 to the power 2 to the power 3, 2 to the power 3, that is 8 graphs are possible. That's why you can see that here the answer is 8. Okay, there are two options: either to take this or not to take this. So we would go at every edges, means the all the extra edges. What are the number of extra edges in case of 4 tree with 4 nodes? It is 3 edges. Okay, so it would be to take it either or not to take it. So that's why the number of graphs we can form is 2 to the power 3, that is 8. So I hope the question is clear now. Let's move on to the solution part. Before going to the solution, let's have a recap of the mathematical concept, some which will be used to solve this problem. Suppose there are n items, and each item can be bought at a cost of C, and where the cost can vary between a range L to R, where L is not included but R is included. Okay, then the total number of ways of buying all n items, that, and also you have been given that you may skip an item, means it's your choice either to take that item or not. So there, so the total number of ways, just remember this case also. Just remember this case also, what we were doing here. How I can say that there are two options: either to take this or either to not take this. So that's why the total number of ways in which we can buy n items is r minus, okay, r minus l plus 1 to the power n. Why to the power n? Because each item will be having r minus l plus 1 option. I am adding 1 because one option is that you may not buy that item. So in total r minus l plus 1. See, r minus l was the values we can assign, because l is not included. So the total number of values, suppose, let me explain. Suppose it is like this 3, so the value should be greater than 3 and it should be less than equals to 5. So the values we can assign is 4 and 5. That's what I am saying, no? So there exist two cost, means there exist two possibility we can buy. We There exists two possibility for this item at which it can be buy. Okay, so 5 minus 3 is equals to 2, and but I am adding 1 to it. Why? Because there exists a possibility that I will not buy this. I will not buy this. That's why I am adding 1. So for each item, suppose if n items are there, so for each item I go to each item 1 2 3 then n, and each item, and each item I will be having r minus l plus 1 option, r minus l plus 1 option. So this quantity r minus l plus 1 is going to repeat n times. So you can now get intuition why I am writing r minus l to the power l plus 1 to the power n. Okay, so now let's move on to the solution part. So what I will do is that I will just follow the Kruskal's algorithm with some modification. Okay, now I have already sorted the edges according to their weights. Okay, now I will discuss. Suppose this was the tree. This was the tree. Okay. So first, suppose I am at this age, and now I am going to add an age between 3 and 5. 3 and 5. Okay. So before adding this age, these two were different components. Okay. These two were in different components. And what was the size of the component? Each component. It was one, and it was one. So I can say that before explaining this, suppose there are two nodes, and these two nodes are part of some different components, and these components is also having some other nodes. Okay, so the size of this component is 3 and the size of this component is 4. So I can say that if I add a edge between any of these, suppose if I try to add a edge between, obviously I am going to add this edge. Okay, so I am excluding this. I have to add the edge between this. Okay, because the edge exists between these two nodes in the initial tree we have been given. Okay, so now suppose I have added the edge between these two nodes. Now what I can say that if I add the edge between any two nodes, means one node should be from this component and other node should be from this component, then it is going to form a loop except this age. Why I am subtracting? Because it was obviously been given that we can't have the multiple edges and this age is already existing with these two nodes. So I can say that what can be the possibilities, suppose if this age was not present. Okay, suppose if this age was not present, then obviously what I would have done, suppose this is the size of the component of the node, the component in which this node is lying, suppose it is u and it is v, and this was the size, as v was the size of the component in which the node v was lying. So what would be the total number of pairs, if I can say su into sv, total number of possibilities of adding edges. But now I will subtract one. Why? Because of this edge, because it is already existing between them. Okay, so now this this you should remember, su into sb minus 1. So the total number of edges we can add between two nodes such that it will form a loop is going to be su into sb minus 1. Just remember this because I am going to use this su into sb minus 1. So what is the sizes here? Corresponding 1 into 1 size of u, suppose it is u and it is v. The size of the component having the node u and the size of the component having node v is both 1. So I cannot add any extra edge where I will be resulting in a loop in the graph. Okay, so it will be 0. Now let's move on to the next edge. Next move on to the next edge. So it was between 1 and 3, 1 and 3, and it was having weight 2. Now, what was the component before adding this age? It was these two components. It was having number of nodes was 1, and this was having number of nodes 2. So the number of extra edges we can add up till now it would be 2 minus 1, that is 1. And you can see also, if I just add this 1 and 5, then this will just give me a loop. And let's decide what can be the possible values of weights I can assign so that my MST is not going to be affected. See, the main idea is that I am only going to add the edges between two nodes only if that is going to form a loop in the graph. Why? Because obviously, if it is going to form a loop in the graph, so that is we will not consider while applying the Kruskal's algorithm, because what Kruskal's algorithm says, we will just neglect the edges between two nodes if it is going to form a loop in the graph. Okay, so yeah, what how I can just determine what is the possible weight I can assign to this edge, means 1 to 5. So see, what is the current weight going on? It is 2. It is 2. Obviously I am going coming from the lower weight to higher weight because I have sorted it. So what is the current weight? So obviously, if it is having value, if I assign weight less than equals to 2, so obviously there might be a possibility that this age will get added first. This age will get added first according to the Kruskal's algorithm. So I will have to assign a weight greater than 2 so that it will not going to affect our MST. So I can assign have it value from 3 to what was the bound? It was 6, 3 to 6. So here I am having four possibilities. And see, there is only one age, there exists only one age which will be having four options. So another option is that I am not going to add this age. Okay, so what can be the possible number of graphs up till now? I can say it will be 4 plus 1 to the power 1. 4 to the power plus 1 to the 1. According to this concept only, what would I have done? N is the number of ages here. N is the number of ages here if I consider. And I have just showed you that only one age exists. Only one at max one age I can form till now, which would result in the loop. And what are the number of possibilities? 4 was the number of possibilities for assigning the values, and 1 was the number of 1 was why I have added 1, because there can be possibility that I have chosen that I will not add the age between these two nodes. So there exist 5 possibilities there. That's why it is 5 into 1 now, till now. So let's move on further. I hope it is clear now what I am doing. Now, the next weight is 3. Next weight is 3 between these two, 1 and 2. So yeah, before adding this, these two were the components. These two were the components. It was having value 1 and it was having value 3. So according to the formula SU into SB minus 1, if you remember, then it is 3 into 1 minus 1. So I can at max add two extra edges, which will result me in a loop. And you can see, if I add as between 2 and 3 and 2 comma 5, then it will form a loop. Now, or what next come is the to decide the weights for them. So what is the current weight going on? It is 3. So obviously I would have to assign value greater than 3, which is 4. So I can assign value 4 to 6, 4 to 6, because 6 is the upper bound of the weight I can assign. So 6 minus 4 plus 1, it would be 3. Now here you can see I will multiply. I here I am maintaining an answer variable, suppose it is 1, and I will keep on multiplying the number of graphs till now. So the number of graphs till now was 5 from this 4 plus 1 to the power 1, and now it will become 3 plus 1. Why I am adding again 1? Because there might be possibility that I will not add. I will decide that I will not add this age, or either I will decide that I will not add this age. Okay, so basically there are two two edges. These these number of possibilities exist for two edges. That's why the it will be 3 plus 1 to the power 2. So I hope now you have got the intuition. Now the next is let me clear this. The next is between 3 to 4. Okay, 3 to 4, and it is having value 6. So before adding, the component was having size 4, and the this was having 4 1. So 4 into 1 minus 1. So I can add at max 3 3 edges. Okay, so let me, yeah, it was having size 4. So 4 into SU into SB minus 1. Just remember that formula: 4 minus 1 minus 1. It is going to be 3. Okay, so I can at max add 3 edges. Now let's talk about the possible weights I can assign to it. What can be the possible weight? It should be greater than 6. Greater than 6. So there doesn't exist any weights. Means I if uh, since it has been out of bounds, so it would be 1 to the power 1 to the power 3, I can say. No, sorry, it would be uh, let's see, it would be yes, it would be power 1 to the power 3. So we can say that the number of graph I am going to get is 5. 5 into 4 to the power 2. 4 to the power 2. 4 into 4. 5 4 is 20 into 4. It would be 80. You are clear now why I have not added any age? Because the weight I can assign should be greater than 6, and the maximum bound we have been given is it should be 6. That's why I can't add any age. I can't add any age. Okay. So 0 plus 1, 0 plus 1, it will be 0 plus 1 to the power 3. So we can get at max 80, and see, the answer was 80. So I hope I am clear with the solution now. Let's move on to the code part. If you are not clear, then just try run over a test case, then obviously you would be clear. So first of all, I would take the t test cases, then n is the number of nodes, and s is the bound of the weight. C input t, then while t minus minus. Okay, and also now I will take the ages factor of pair int comma pi. What is pi? It is basically I have created a macro for the pair int comma int. Okay, now for int I is equals to 1, I less than n, I plus plus, I will take the input u comma v comma w, u d w. Then obviously I would add in this manner. First of all I would add w, then I would add u comma v, then I will sort every edges. It is pushed back. So it will just return all the edges in the sorted order of their weights. Okay, and now let's create the PSU. I will be having size vector, then parent obviously, and If you don't know, then you should first learn the DSU. Now what I will do is that I will keep a answer variable, answer is equal to 1. Now I will go to, see one thing which I have discussed, the power which I was taking, it can be very large, and that's why we have to take the modular. So this can be done using the modular exponentiation. So yeah, you should also know the binary exponentiation. Now I would go to every edges it dot second dot second. Then second node would be it dot second dot. Sorry, it will be first. Yeah. And w is equals to it dot first. It is stored in it dot first because see how I have stored. That's how I am just extracting the u, v, and w. Now let's first create the DSU into find into b, if b is equals to per b. So we are done with the DSU. Now int pa int pu is equals to the parent of u. So how I can find it is u. Then pv, it is the basically why I am doing so, I am just finding which component it belongs to. If it is belongs to the same component, that there doesn't exist any point to add the edge. Why? Because it will leads to it will just form the loop. Okay. If pu is not is equals to pv, then before adding the edges, just obtain the edges. What I can say, possible weight I can assign. It is pos b. I am possible weight I can assign to the edge. Okay, means suppose I've already explained, but let me explain again. If I am adding the age between 2 and 1, suppose I am adding the age between 2 and 1, then before adding this, what was the size component size? It was 3 and 1. Okay, it was 3 and 1. So obviously, using find operation, I am just finding the size of this and this. Okay, I hope now it has become clear. The possible value was the current weight. It was the current weight, the upper bound, then weight plus 1. Because basically we have to assign the weight between w plus 1 to s. Okay, and why I am adding plus 1? Why I am adding plus 1? I have already explained that there exists an option that I would not just select this. I am not going to select this age. And what will be the possible ages, possible number of ages, possible number of ages I can add, means I am talking about this. What will be the possible number of ages? Su into sb minus 1. Just remember that Su into sb minus 1, I have already explained Su into sb minus 1. So that's what I will do. S of pu means the size of the component in which the node u lies, into size of pv, then minus 1. Now answer is equal to answer answer modulo mod into 1ll into binary exponentiation cos b, comma, possible ages, possible number of ages. We'll take also mod here. think I would have to take union of u comma v. Now, we only thing we are left with is to create the binary exponentiation function. In binary exponentiation, xp in a into b. Suppose we have to find a to the power b modulo m. Okay, so int result is equals to 1. I would say a mod, then while b is less than 0, greater than 0, I can say if b modulo 2, then res is equals to res modulo mod into 1ll into a to the power a mod m, then mod. So each time I will just make it half. You should learn binary exponentiation to understand this. Then a is equals to a into 1ll into a, then take more of it, return less. So yeah, that's all about the code. Let's run it. You can see that it has passed. So the binary exponentiation basically returns in log and time complexity e to the power b mod m. Okay. So yeah, thanks for watching.